Alright, today's lesson is over dividing complex numbers. Now, as a refresher, remember that when we talked about multiplying, the very last problem we came across something called a conjugate. A conjugate is simply a complex number, like 2 plus 4i. Let's use a different color here, excuse me. Let's say 2 plus 4i. To create the conjugate for this complex number, all you would have to do is change the sign from a positive to a negative. Now let's create another one. Let's say 7 minus 3i. The conjugate for this complex number would be 7 plus 3i. Nothing else changes except for the sign on the inside. Now what happens when we multiply a complex number to its conjugate is that it gets rid of the imaginary part. That is super important because, like radicals, we don't want imaginary numbers in the bottom of a fraction, because if you remember, I is the square root of -1. We don't want square roots or radicals in the bottom of our fraction. So how do we get rid of them? So first off, before we get too busy, let's find the conjugate of 2 plus 3i. Remember, all we need to do is change the sign so it's 2 minus 3i. Now what will happen when we multiply these together? So if I multiply 2 plus 3i to 2 minus 3i, 2 times 2 is 4, 2 times negative 3i is negative 6i, 3i times 2 is 6i, and 3i times negative 3i is negative 9i squared. But remember, the I squared is actually a -1, so this becomes a plus 9. So by organizing and adding our like terms, 4 plus 9 is 13, excuse me. Woo. Must be tighter than I thought. And then 6i plus negative 6i is 0i, so we are left with 13. So the imaginary part went away. Alright, what I'd like for you to do is pause and see if you can do the same. Find the conjugate for the complex number 4 minus I, and then multiply them together. You should end up with just a real answer. Alright, so you should have found 4 plus I is the conjugate for the complex number 4 minus I. When we multiply them together, 4 times 4 is 16, 4 times I is 4i, negative I times 4 is negative 4i, and negative I times I is a negative I squared. Now we come across something interesting, negative I squared. In front of this I squared is a 1. So what's going to happen is -1, and remember I squared is -1, so -1 times -1 is a plus 1. The 4i and negative 4i result in a 0i, so 16 plus 1 is 17. So how do we divide complex numbers? First thing that we need to do is find the conjugate of the bottom and multiply both the top and the bottom by the conjugate. Okay, the reason for this is that we cannot have complex or imaginary numbers in the denominator of a fraction. Alright, so here we do. I want to take this bottom number, 1 minus 2i, and I need to find the conjugate for it. Now the conjugate for this is simply 1 plus 2i. So I would multiply both the top and the bottom by 1 plus 2i. Alright, so what we want to do is I'm going to actually separate this. And I'm going to do the math for the top and the math for the bottom separately. And you'll see why in a minute. Alright, so we would do 8 plus 3i times 1 plus 2i. So we have two multiplication problems for here. Let's go ahead and extend this page a little bit. So 8 times 1 is 8. 8 times 2i is 16i. 3i times 1 is 3i. And 3i times 2i is 6i squared. Remember, I squared is really -1, so this turns to a -6. 8 plus -6 is 2. 16i plus 3i is 19i. So the top of our fraction is going to be 2 plus 19i. Alright, let's multiply the bottom. 1 minus 2i times 1 plus 2i. So 1 times 1 is 1. 1 times 2i is 2i. Negative 2i times 1 is negative 2i. And negative 2i times a positive 2i is a negative 4i squared. As I squared is negative 1, negative 4 times negative 1 is plus 4. So we have 1 plus 4 is 5, and then the 2i and the negative 2i result in 0, so the bottom of our fraction is simply 5. So the answer to the question, 8 plus 3i divided by 1 minus 2i, is 2 plus 19i over 5. We know we did this correctly because there was no imaginary number on the bottom of the fraction. If I still had an I on the bottom of the fraction, it means I did something incorrectly. Alright, so let's go ahead and give this one a shot as well. Remember to go ahead and find the conjugate of the bottom. So I would simply multiply by 3 minus 4i, and what I do to the bottom, I must also do to the top. So let's go ahead and divide our page again like what we did on the previous slide. We'll have the top and the bottom. Alright, 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative 2i times 3 is negative 6i. Negative 2i times negative 4i is plus 8i squared. Alright, so negative 20i and negative 6i is negative 26i. We have to be careful because I squared is really negative 1. So this becomes 8 times negative 1, which is negative 8. So 15 times, or plus negative 8. Well, I shouldn't put a box around that. That's not our final answer, excuse me. So 7 plus 26i is the result for the top of the fraction. Alright, now we know if we did this correctly, the bottom should result in just a real number. No imaginaries, no nothing. So 3 times 3 is 9. 3 times 4i is negative 12i. 4i times 3 is positive 12i. I'm already noticing these are going to cancel each other out because they result in 0. So I'm on the right track. 4i times negative 4i is negative 16i squared. Remember, I squared will change the sign, so this is a plus 16. 9 plus 16 is a 25. Oh, I should not circle that answer, as that is not our final answer. However, I can put the 25 in the bottom of the fraction, and 7 minus 26i over 25 is my final answer. Alright, so this problem looks a little different because the top does not have a complex number. However, it's done exactly the same way as our previous problems. You would still multiply the top and the bottom by the conjugate of the bottom. So you end up having two separate multiplication problems. So we have the top of the fraction and the bottom of the fraction. So the top is 4 times 5 plus 2i. What's nice about this is that all I have to do is distribute the 4 in. I don't have to FOIL or box or distribute a whole bunch of things. These are only two multiplications. So 4 times 5 is 20. 4 times 2i is 8i. So that's easy. That's the top of our fraction, 20 plus 8i. Now for the bottom of our fraction, this is where we go back to distributing and either using the box method or FOIL to remember to multiply everything together. So 5 times 5 is 25. Okay, 5 times 2i is 10i. Negative 2i plus times 5 is negative 10i. And negative 2i times a positive 2i is negative 4i squared. Remembering that I squared changes the sign of the number in front of it. So 25 plus 4 is 29. So our answer to this division is 20 plus 8i over 29. We know we did this correctly because there is no longer an I in the bottom of the fraction. Alright, now with this one it looks a little different because the number on the bottom is still considered a complex number except that it has a 0 plus in front of the 5i. So the conjugate for the bottom is actually going to be 0 minus 5i, or we can just say negative 5i. So when we multiply the top and the bottom, we would make sure that we multiply them both by negative 5i. So again, we have two multiplication problems to do. So the top is simply going to be negative 5i times 4 plus 3i, and the bottom is going to be 5i times negative 5i. The bottom's pretty easy. This was going to result in negative 25i squared. Remember, I squared is negative 1, so this is 25 on the bottom of my fraction. Okay? And then we need to distribute the negative 5i to the 4 and to the 3. So I have negative 20i, and then negative 15 times 3 is negative 15. Or excuse me, negative 5 times positive 3 is negative 15, and I times I is I squared. So this is actually going to result in a positive 15. Now be careful here. We want to make sure that we write it in the form of a plus bi. So it's 15 minus 20i is going to be the top of ours. So we put 15 minus 20i. Now here's one other thing that we can do. So this actually looks like our final answer. However, I have noticed that there is a number that will go into 15, 20, and 25, and that is 5. So I can actually simplify this by pulling out a 5. So it would be 5 is 5 times 3 minus 4i, because if I were to redistribute the 5 in, it would be 15 times negative 20i, over 5 times 5, because that's what 25 is. Notice that 5 over 5 is 1, so my simplified answer is 3 minus 4i over 5. So this right here is actually going to be my final answer. Alright, that's all we have for today over dividing complex numbers. Make sure that you are okay with complex numbers, how to write them, how to simplify them, how to add and subtract complex numbers, and how to multiply and divide complex numbers. If we have an assessment or a quiz, I would like for you to be prepared. If you have any questions, just let me know or come see me during one of my tutoring times. Thanks so much. I'll see you guys later.